Good morning to you all. My name is Rosalia Malundilange and I'm taking you through quantitative method 1. This is a second year module, degree level. Okay, my contact details are as seen on the screen. You can call me for any assistance on this module. Let's quickly start with what is quantitative method. Now, you should have known by now that quantitative method is a statistical module. Okay, and what is the meaning of statistic? Statistics is a scientific process. Okay, this process is for collecting, organizing, summarizing, presenting, and analyzing data. Why do we do this? Is because we want to get meaningful conclusions, and then on the conclusions we can make reasonable decisions based on the data that was analyzed. Okay, according to the definition that I just gave you, it have 4 stages: collecting, presenting, analyzing, interpreting. Okay, but what is collection? The collection is the first step of the entire process of collecting data, right? Now, what do you do there? This is when you collect the information from the primary or from the secondary data, or wherever you do it. Then you have to present it. How do you present data? In presentation, you want to make the data look concise, so that it will be easier for the people that get hold of it to understand it. You can either do it in tabular forms or graphic forms, whichever way you want to do it. Then you have to analyze. When it comes to analysis of data, there are some statistical packages that you can use, but for your level you can still use Excel to analyze your data, to get the tables, to get the graphs, to get the percentages and all that. Then after that you have to interpret what you have got in your analysis. Now, statistics have 2 branches. Okay, the branches of statistics are the descriptive statistics and the inferential statistics. The descriptive statistics is just the collection, the summarizing, and the organizing and presentation of data. But inferential statistics, this is now when you make inferences or you make conclusions depending on the data, on the outcome of the analysis. You are making inferences. Okay. And then there are terminologies that are very, very important in statistics, which is quantitative methods, that you should know how to define. Now, if you have got hold of your assignments, you see that these are important terms that you need to know how to define and what they mean, because they are used throughout the whole subject. For example, you need to know what is data, what is population, the 2 types of population, census, what is a parameter, and what is a sample. Okay, now all those you can read on your own. You also need to know what is sampling. Sampling is very important. And what is sampling? Sampling is just the process on how you select a sample. Whenever you are doing a research, you do not want to use the whole population because of some reasons that we all know. If you have to use the whole population, then it will mean it's time consuming. You have to spend a lot of money. You might not even finish on time. That's why you have to take a sample which should be a true representative of the whole population and work with that sample. Now, sampling is just the process on how you get that representative subset. Okay, and then the very important other thing is the type of variables. Remember, we have 2 types of variables. We have qualitative random variables and we have quantitative random variables. The qualitative, these are non-numeric variables. When you talk about the gender of a student, male or female, those are qualitative. Why? Because they are not numeric. Okay, now most of you, when you are asked to differentiate between qualitative and quantitative, you say qualitative data is the one for quality, And quantitative data is the one for quantity. You did not explain what they mean. Qualitative random variables are non-numeric variables. They do not take on numbers, but quantitative variables are the ones that take on numeric variables. Okay, for example, the age of a student, that is quantitative. Okay, and mostly in statistics we use quantitative random variables. Then we also have discrete variables and continuous variables. Okay, now under quantitative variables, the variables are still grouped into two: discrete and continuous. All of them are quantitative, but the difference is the discrete random variables take on exact numbers on an interval. Let's say you have an interval of 0 to 5. So a discrete random variable will either take 0, 1, 2, 3, 4, or 5. But a continuous random variable will take on any value on an interval, not only whole numbers, but any values, including the decimals. Okay? Data sources or data categories. The data are into two categories. You have primary data and you have secondary data. Primary data, these are first-hand information collected at the point where it's generated. Okay, and it's collected for the first time with a purpose at hand. But secondary data, these are informations that are already collected by someone. Okay, it's not first hand. You are not going to get it from the point where it's generated. Someone already got it from the point where it was generated and has processed it. Now for you, it's second hand information. Now that makes it secondary data. This information was collected by someone for a purpose rather than the purpose at hand. So you are going to use the information for something else that the first person that collected it did not use it for that specific reason. Okay, we move on to the second data source. We have internal and external. Internal data source, these are informations that you get within the organization that you belong to. Since you are IOL students, whatever informations that you get within IOL, then that is internal data for you because you belong to the organization. But external is what you get out of your organization. Okay, there's three methods on how we collect data: through observation, through interviews, and through experiments. Now there's a lot of different ways of interview methods that you can read on your own. Now let's look at the two basic methods of sampling. Remember, I said sampling is very important. The process on how you select a sample, and a sample is a subset of a population. Okay, how do we collect a sample, or how do we select a sample? We do it in two ways. It's either using the probability sampling method or the non-probability sampling method. When you're talking about probability sampling method, which is also known as the random sampling, this is when every element of the population have an equal chance of being selected to be in a sample. Okay, because it's done at random, so every person or every individual have an equal chance of being selected to be in a sample. While non-probability sampling, not every element of the population have an equal chance of being selected to be in a sample. Under probability sampling methods, there's 4 types. There's simple random sampling, there's systematic sampling, there's stratified, and there's also cluster. But in non-probability, you have, for example, convenience, you have judgmental, you have snowball. Just to give you an example of non-probability random sampling, let's look at simple random sampling. Now you want to get or to select a sample from the whole population. How do you do it? Let's say, for example, you are a student and you want to select other students within your institution to be part of your sample, or the people that you are going to deal with, to get the informations that you need. So what you do is you stand at the gate and then you decide, I'm going to pick every fifth person that is entering the gate. Now that means that every element or every individual, every student have an equal chance of being selected to be in that sample, because you never know, you might be the fifth person. You are not counting, but you are just entering the gate. But for judgmental, for example, in non-probability sampling, this is not random. The person will use their own judgment. They will look at someone and say, no, this one cannot be in my study, this one can be in my study. Okay, there you can see that there is no equal chances. So whenever you are doing your studies, when you are doing your research, the method that you should use to obtain the elements that you are going to include in your research should be done using probability sampling. Let's quickly move on to measure of dispersion. In measure of dispersion, which is also known as the measure of central location, we want to find one value that can describe the whole population. Okay? And also in dispersion, we want to, this is measure of dispersion, so we want to know how far or how spread out the data is. But in measure of central location, where we learn of the mean median mode, there we want to find one value that can be used to define how the other elements in the data set are. Okay, but in dispersion we want to know how spread out the data set is. Now the common measures are range, quartiles, which you can get interquartile range, quartile deviation, variance, and standard deviation. What is the range? For you to find the range, is just you take the highest value in the data set minus the lowest value. That gives you the range. And then the quartiles. When it comes to quartiles, the way we calculate for ungrouped data is not the same as for grouped data. Now, I don't know if you know the difference between ungrouped data and grouped data. Ungrouped data, this is raw data. You have 8, you have 16, you have 5, you have 2, you have 11. That is ungrouped, okay? It's not because it's not in ascending order or descending order, it's because it's not in any way brought together to form up a group. But a grouped data will be something in the form of, we are going to take all numbers between 0 and less than 10, okay, and then let's say from 10 to less than 20, and then 20 to less than, let's say, 40. Now this is grouped because numbers between 0 and 10 are brought together. This can be called an interval. And then you also calculate the frequency. How many numbers are between 0 and less than 10? If you say less than 10, it means you are going to start from 0 up to 9. Then you can count them on the raw data that you are given, and then you find that there are 4. For example, here you get 5, and then you get 7. Something. Now this you can see it's grouped because values are brought together to form a group. Now the way you calculate the quartiles or the mean median mode for ungrouped, which is this one, is not the same as how we calculate for grouped, which is that in a table form. Now quartile 1, which is always called the lower quartile, this is the 25th percentile. Okay, now quartiles divides the data set into 4 equal parts. We have quartile 1, which is the 25th, quartile 2, the 50th, and quartile 3, the 75th percentile. Okay, now for you to get the interquartile range, you just get the difference between the third quartile and the first quartile. And then the quartile deviation is just the quartile 3 minus quartile 1. The answer, you divide it by 2. Now there's formulas on how to find the positions of the quartiles. Now these formulas is just to find the position of the quartiles, but not the values of the quartiles. Okay, for the lower quartile, which is the first one, is n plus 1 divided by 4. Now if you're on your calculator, you press 1 over 4, you get 0.25, and 0.25 multiplied by 100, that is 25th percentile. Okay, or 3 divided by 4, it will give you 0.75, multiplied by 100, you get 75th percentile, which is very easy for you to remember. Okay, let's say you are given an example of an art group data. You have 3, 5, 6, 9, 15, 27, 30, 35, 37. Now, whenever you are given these examples, you should first see if the data is arranged in ascending order. Should start from the smallest to the biggest. Now you can calculate. Okay, one thing that I should not forget when it comes to ungroup data, the way you calculate quartiles for an odd data set is not the same as for an even data set. Now when we are talking about an odd data set, we are looking at the number of elements in the data set. Does it take an odd number or does it take an even number? The example that we are given here, there are how many? There are 2, 4, 6, 8, 9. 9 is odd, so that is an odd number. You are not looking at individual elements in the data set, you are looking at the total number of items in the data set. Okay? And then an even data set, when you count them, if n gives you, for example, 8, it gives you 10, it gives you 12, or 6. N is that or n is that. Okay, you can say n is even, 8 is even, then 10 is even, then that is an even data set. Okay, if you calculate the position of the first quartile, n is 9 plus 1, it becomes 10, then 10 divided by 4, it will give you 2.5. That means our quartile is on the middle of 3, not 3, but 2 and 3, isn't it? Because 2.5 is between 3 and 2, exactly in the middle. Okay? What is on the second position of our arranged data set is 5. And what is on the position of the third on the third place in the arranged data set is 6. Now you have to take average of the second and the third number in the arranged data set, which is 5 plus 6. You divide it by 2, then the value of your quartile is 5.5. 2.5 is just the position, but 5.5 is the value of the quartile. Okay? Now let's go to the third one. 3 multiplied by 9 plus 1, which is 10. 10 multiplied by 3 is 30. 30 divided by 4 will give us 7.5. Then that value 7.5 shows us that the value of our quartile is between the 7th value in the arranged data set and the 8th one. Why? Is because 7.5 is in between 7 and 8. So you take average of the two values on the 7th position, this position, and on the 8th position. Okay, on the 7th position you have 30, and the 8th you have 35. You add them together, divide by 2, you get 32.5. Now the interquartile range, which we call the IQR, will be the third quartile minus the first quartile. 32.5 minus 5.5 will give you 27. Now for the quartile deviation is Q3 minus Q1 divided by 2, which will give you 13.5. Now what do these quartiles mean? Let's say this data that was given here is the scores of the students that they obtained in the quantitative method test. Now what does the value of 5.5 mean? It means in that class 25% of the students got below 5.5%. And if you want to interpret this, the third quarter, which is 32.5, it means 75% of the students in that class got below what? Got below 32.5% or 32.5 marks in the exam or in that test. Okay, we move on to variance and standard deviation. The formula, I hope you can see it clearly. Remember the example that we just finished on quartiles is for an odd data set. So you need to read on how to find the quartiles of an even data set when the data is ungrouped. Okay, the formula for variance there, variance, which is known as s to the power of 2. S to the power of 2 is the sum of all the x values minus their mean, and you square it, divide by n minus 1. That is the formula. Now, for the standard deviation, which is s is just the square root of the variance. So when you get the answer of this, the variance, put it in the square root, it gives you the standard deviation. Okay? And that is for an ungrouped data set. What is x bar? I hope we know what is x bar. X bar is the mean. Okay? Remember we say x bar is the sum of all the variables divided by the number of items in the data set. That is x bar. Okay, and then the second step says you should subtract each x value minus the mean. After doing that, you have to square the mean. Not to square the means, but to square the deviation. When you take the x variable minus the mean, that is called a deviation. Now, for standard, for variance, you need to square the deviations. All what I'm saying is shown in this short example here. Let's say the xi's, these are the variables that you are given. You are given 4, 7, and 10, and you are asked to find the variance and the standard deviation. What you need to do first is to find the mean of this. The mean of that will be x bar is equals to 4 plus 7 plus what? Plus 10. And you divide it by what? 1, 2, 3, 1, 2, 3, and that will give you what? It will give you 7. So the mean is 7. So what do you do next? You need to take each variable or each data element and minus the mean as shown on the table. After that, square all the answers that you got on the second column and you get your answer of 18. Now that 18 is what you have to put here. You are going to put, that is the sum of the deviations squared. And then you divide it by what? You divide it by n minus 1. You need to divide it by n minus 1 always, because whatever amounts you are given is calculated from a sample. Okay? But if it's from a population, then you have to divide by n only. Okay, then the standard deviation will be the square root of 6, and the square root of 6 is 2.2449. Okay, another example that I'm giving you there. Remember the formula that you have here, that you have on this slide for variance is not the same as the one that you have on this slide. The difference is, on the current slide, this variance is for a sample. But on the other slide where I just moved from is for a population. Okay? Then we come to the economics part. The cost, revenue, and profit function using break-even analysis. Now, if you look at the past question papers, this question always comes. Why? Because it's very important on how to calculate the break-even analysis of a company. Okay, Let's say, for example, you are given that simple example there. The chicken farmer produces chicken at a production cost of that, and then the revenue function of that. Sometimes the cost function and the revenue function is not given to you, but you have to form them yourself based on the information given in that scenario. Okay? You should know that profit. Let's start we'll start with the revenue function. Okay, I think it's somewhere under the slide here. Okay, the revenue functions, those were already given to you. Okay, but it's fine, just go through the slide and then you will understand what this thing's all about. It's very simple. To find the break-even level, you just equate the two functions. The cost function, you say it's equals to the revenue function, and then you calculate the break-even. The break-even there, what you are going to calculate is to look for the value of x. Okay, you are given 80x plus 120, which is equals to what? Which is equals to 200x. Collect like terms on one side. This term and this term are alike. You bring them on one side and then take the 120 on the other side. So for x, and that is done for you there. So for you to break even, you need to produce only 1 unit. Okay. Then you move on to supply and demand function. The supply and demand function, you are always given the demand, the supply function, and you are also given the demand function. So you are always asked to calculate the equilibrium price and quantity. Now for you to calculate the equilibrium price and quantity, you still have to equate the two equations and solve for Q. Now when you solve for Q, that is the equilibrium what? The equilibrium quantity. Therefore, you will need to calculate the equilibrium price by substituting the quantity in either the supply function or the demand function. Okay? You need to read further on the binomial distribution, the Poisson distribution, and the normal distribution. Thank you very much. Until next time.